Here's a short video on the guts of this General Electric 175 watt high pressure mercury floodlight. Well, it's high pressure mercury or metal halide. In this case it's fitted with a metal halide lamp, but high pressure mercury would also work. Very interesting thing in the way that the ballast can be adapted to different potentials, because it's got a somewhat interestingly designed quad tap ballast. You see a whole buttload of wires. However, there's a selector plug in here where you can set it to either 120, 208, 240, or 277 volts. And it changes the taps very easily instead of having to change around wires. And there was a card in the fixture which shows that for the 250 and 400 watt versions of it, there'd be a selector plug for that as well. So, very convenient. Especially for something where these are, a lot more reliable and resilient than the electronic garbage used for LEDs. Of course, the terminal block, which is capable of taking fairly large wire, and also that's easy for a 200-pound gorilla installing the thing to use. There is the metal halide lamp that the fixture is fitted with, starting resistor, and that gives was right on the end is the starting electrode shunt. So, if you've seen the video I did on one of those high pressure mercury lights, that 1 kilowatt one, I was talking about how the lamp needs a shunt to prevent corrosion or electrolytic decomposition of the quartz when the lamp is in operation. That's what that switch looks like. It's, again, very simple. It's just two pieces of metal. Also, another way that you can tell the little discharge tube is high pressure mercury is that it wouldn't have that infrared reflective coating on the ends of the discharge tube, which can be zirconium oxide, aluminum oxide. The Russians would use chromium oxide, which has a very distinctive green color, because, Russia. But yeah, very interesting stuff, and worthy of keeping this knowledge alive. And as an experiment I'm doing with this metal halide fixture, there's it running on its original 175 watt metal halide lamp. Yeah, this is just for testing purposes, as well as to dry the fixture out because there's a little bit of moisture in it. Totally safe electrical connection, but again, this is being done under direct supervision. And there's its operating power, bouncing around between 233 and 238 watts. And it's stabilized at that level. And then what I'm going to do is I'm going to test run a 175 watt merc in it. See what that does. And that same metal halide fixture with a fully run up high pressure mercury lamp. 207.6 watts. So an almost 30 watt power reduction running a high pressure mercury lamp versus a metal halide, which has to do with the electrical characteristics of the lamp and how it deals with the ballast. Because a metal halide lamp, when the arc is actually conducting, the operating potential is lower, but at the same time it needs a higher potential at the start of each half cycle to get the arc going. That's one reason why peak lead ballasts for these things are so common, because they better do that.